Measures of position is a number that tells where the score stands relative to the others in a set of data. It is a measure whether a value is about the average or whether it is unusually high or low. It is used for quantitative data that falls on some numerical scale, and this can be applied to ordinal variables. This includes quartile, decile, and percentile. In this video, we will be focusing on quartiles. Quartiles divide a rank order dataset into 4 equal parts. And this is the formula that we're going to use, wherein Q represents quartile, I is the number of quartile, and N is the number of samples. You see this TH here, it means the number being obtained here represents the rank or the position in our given dataset. Let us consider this given. So in a score of in a 20-item quiz of Math 10 fame, these are the scores. We're going to find the quartile 1, quartile 2, quartile 3, and the interquartile range of this given data. So using this formula. So step 1, we're going to arrange the scores in ascending order. So from lowest, which is 7, going to the highest, which is 20. Then after that, we're going to count all the numbers of data, and that is 19. We can now start solving for the quartile 1. So using that formula, we're going to substitute. Our I here is 1 since we're looking for the quartile 1. So I is replaced by 1. Then our N here is 19. Then 19 plus 1 is 20. 20 times 1 is 20. 20 divided by 4 is 5. So this tells us that quartile 1 is located in the 5th rank in our given data set, which is arranged from lowest to the highest. So in here, the 5th rank or the 5th position is number 15. So therefore, our quartile 1 is 15. To solve for the quartile 2, we'll be using the same formula. Then substitute I with 2. Then our N here is the same, which is 19. So 19 plus 1 is 20. 20 times is 40. 40 divided by 4 is 10. So it means our quartile 2 is located in the 10th place or 10th rank, and that is 17. So our quartile 2 is 17. To solve for quartile 3, using the same formula, substitute I with 3 since we're looking for the quartile 3. Then 19 plus 1 is equal to 20. 20 times 3 is 60. 60 divided by 4 is 15. So our quartile 3 is located in the 15th position or 15th rank in our given data set, which is 20. Therefore, the quartile 3 is 20. Now, to solve for the interquartile range, we will just simply get the difference of the upper quartile, which is Q sub 3, and the lower quartile, which is the Q sub 1. So our Q sub 3 here is 20. Our Q sub 1 or quartile 1 is 15. So 20 minus 15, that is 5. So our interquartile range is 5. In our given number 2, the owner of a tea house recorded the number of customers who came each hour in a day. The results were 28, 19, 10, 10, 16, 18, 21, 15. Find the quartile 1, 2, 3 and the interquartile quartile range. So same process. Step 1 is arrange the scores in ascending order. Then count the number of data, and that is 8. Then to solve for quartile 1 using the same process. So our N here is 8. So 8 plus 1, that is 9. Times 1, 9, divided by 4, 2.25. Notice that in our given number 1, our N there is an odd number. In here, it is an even number. So there's quite difference in finding their quartiles. So in here, it is 2.25th rank in our given. So we're going to locate that. So this is the first, this is the second. So it means this 0.25 here is located between 10 and 15. So 0.25, that is 1/4. So how are we going to compute that? So this is the 2.25th. So it is somewhere here. Now, second rank plus 0.25 or 1/4 of the difference between the third rank and the second rank. So our third rank here is 15 minus 10th place, which is, second place, which is 10. So 15 minus 10, that is 5. 5 times 0.25 is 1.25. Added by the second rank, which is 10. So 10 plus 1.25, that is 11.25. Therefore, our quartile 1 is 11.25. that is the 2.25th rank in our given data set, arranged in ascending order. So to solve for quartile 2, so change or replace I with 2. Then our n is 8. 8 plus 1 is 9. 9 times 2 is 18. 18 divided by 4 is 4.5. So 1, 2, 3, 4. Our quartile 1 is located in here. So 4.5, so that is between 16 and 18. So intuitively, we know that that is 17. So to solve for it, so 4, then 0.5 of the 5th minus the 4th in our data. So our 5th data here is 18 minus the 4th data, which is 16, and that is 2. 2 times half or 0.5 is 1. 1 plus 16 is 17. So our quartile 2 here is 17. To solve for quartile 3, using the same process, change I to 3, then our n is 8. 8 plus 1 is 9. 9 times 3 is 27. 27 divided by 4 is 6.75. So that is somewhere here. Then, to solve for it, 6 plus the 0.75 of the 7th minus the 6th place. So our 7th place here is 21. Then the 6th place is the 19. So 21 minus 19 times 70.75, that is 1.5, plus 19, and you will get 20.5, and this will be our quartile 3. To solve for interquartile range, just simply get the difference of quartile 3 and the quartile 1. So our quartile 3 is 20.5, our quartile 1 is 11.25, and the difference is 9.25, and this is our interquartile range.